Hi guys, it's Mrs. Millison. We're going to do the Check You Understand on page 514, which is practice finding our critical T values. Okay, we're going to use table B. Sorry, Kitty's getting in the video. We're going to use table B to find the critical value T that you could use for a confidence interval for population mean mu in each of the following settings. And if possible, check your answers with technology, which is your calculator, which we'll do. Okay, the first one is a 96% confidence interval based on a random sample of 22 observations. Okay, so in order to use our table, we're going to have to find the intersection of 96% confidence interval and not the sample size, but the degree of freedom, DF. The degree of freedom is simply sample size minus 1. So, of course, in this case, our degree of freedom is 21. So we're going to find the intersection of 96% confidence interval and degree of freedom of 21. So if I come to my T table, and I'll give you a copy of this when we get to class or in class, down at the bottom are my confidence levels, okay? So we'll go to 96% confidence level, and then on the side here are my degree of freedoms. So we have to go to degree of freedom of 21. So if I go to the intersection of 96% confidence level and degree of freedom of 21, I get a T of 2.198. Okay, I get a degree, or a critical T of was it 198 or 189? I think I messed it up. 96, 189. Okay. To check it on the calculator, we need to do kind of the same thing we did with our critical Z. So if this is the middle 96%, okay, we have to figure out the rest of these are 4%, so half of them is 2%. So this critical T is looking at 98% to the left, okay? So in our calculator, move this up a little bit, in our calculator, under second vars or distribution, we have an inverse T command. And in the inverse T command, we're going to put the area to the left. So in this case, it's 98, okay, 98%. And our degree of freedom, which we said was 21. Okay, so here you can see it matched perfectly. Okay, so even using a calculator, let me write this out. Inverse T, 0.98, comma 21. We got our critical T as the same thing. Okay, and again, just like critical Z's, always take them to 3 decimal places. Okay, all right, next question says we want to do a 99% confidence interval with an SRS of 71 observations. So here we have a 99% confidence interval with 71, a sample size of 71. So let's do our degree of freedom. Of course, this is 70. So on the table, we're going to find the intersection of 99% confidence interval and a degree of freedom of 70. So if I come down to the bottom, there's my 99. Now, if I go over to my degree of freedoms, I don't have a 70. Okay, I got a 60 and an 80. Well, we're always going to go conservative. Since 70 is between them, we're going to go always less. So we're going to go with a degree of freedom of 60. So if I go 99 and then my degree of freedom of 60, I get a critical T of 2.660. Okay. Okay, now that truly is an estimate because we didn't actually have a degree of freedom of 70 on our table. So when we do it in the calculator, it's going to be more exact, of course. So again, this is our 99%, which means this total is 1%, which this is a 0.5%. So this critical T will look at the area of 99.5% to the left. So in my calculator, I'll do inverse T of 99.5% with a degree of freedom of 70. And let's see what I get. Okay, inverse or second vars, inverse T, 0.995. Oops, my degree of freedom of 70. And I get a much more accurate T. Okay, so this will give me a much more accurate critical T of 2.648. Again, always rounded to 3 decimal places. Okay, it doesn't matter on the AP test whether you use the table, or the calculator. Personally, you're probably going to use the calculator. It's definitely more exact. Okay, but I would give some indication of what you're doing. Draw your little curve, write down what you're putting in the calculator so they know what you're doing. Okay, that's it for that one. See you next time.